This lesson is for Advanced Algebra Lesson 1-8 on explicit formulas for sequences. We will talk about sequences a couple other times this year, and we will learn some other formulas for sequences. Today we're just going to focus on the explicit formula, and what's nice about the explicit formula is that it can be used to generate any term of a sequence. The main sequence that the book emphasizes in this lesson are the sequence of the triangular numbers, and it's simply pictured here as the number of dots that form into a triangle. And so we're going to make a chart here to help us understand where this formula came from. So this is the first term in the sequence. So it's term number 1, and it has 1 dot. The second term in the sequence has 1, 2, 3 dots. The third term in the sequence has 1, 2, 3, 4, 5, 6 dots, and then you can kind of see where we're headed here. The next term in the sequence is term number 4, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So if we were trying to make a table and talk about our two variables here, we've got n representing the number of terms, or the term number that we're on in the sequence, and then the actual number of dots representing the sequence itself. So the actual list of numbers. So the sequence we're generating here, called the triangular numbers, are the numbers 1, 3, 6, 10, and so on, indicating that there are other numbers to this sequence that we have not yet indicated. So when we write the formula for an explicit formula for this sequence, the capital letter stands for the name of the function, and then typically you'll have a subscript here, and that is typically the n. Typically your n will be the independent variable letter used rather than x, and that is the term number that you're on. And so when you want to find term number 100 in the formula, you can simply plug in 100 for n, and the formula will generate the number in the sequence that you're looking for. Sometimes in this lesson they will give you the formula and ask you to generate the numbers. For the most part, that's what's going to happen. Sometimes they'll have you working backwards. So let's go ahead and look at some particular examples. So consider this sequence, 2, 4, 6, 8, and so on. And then they give you the formula. This time it's a lowercase t. Typically they do use capital letter t's, or capital letters to indicate sequences. But they do have a subscript n, which indicates we could plug in the term number. So if they want us to do t sub 5, that means they want us to find the 5th term in the sequence. And so the way that we would do that is we would plug in 5 for n. So I'm going to take the formula, t sub 5, and I'm going to say 2 times the n value which I got, which was 5. And you can do that either with the times there or with the parentheses. It really doesn't matter. And so we know that the answer there is going to be 10. And I neglected to on our earlier problem. Let's just pretend here that one quick thing I wanted to mention is, what if you wanted to get term number 50 or term number 100 like we were talking about? You could simply plug in t of 50, and you could go ahead and calculate half times 50 times 50 plus 1. And so now you could just utilize your calculator there, and we could type it in as is. We could also do probably a little bit by hand here, or a little bit mentally. We know that 50 plus 1 should be where we would start because of the parentheses, so we get 51 there. And then we already know that half of 50 is going to be 25. So we can simply type in 25 times 51, and we'd be able to get the number in the sequence that is the 50th triangular number, which would be 1275. So I should have had you look at that before we looked at our first example. Let's go on to a second example, going a little bit further now with the whole idea. By the way, also back here I wanted to point out how you read this out loud. You would say t sub 5. So it is a subscript, but when we read it aloud we just simply say sub. On the next example, we're going back to using our capital letters like I prefer. So this is sequence S. N is our variable, n representing number of terms. And they give us the formula straight out. Sometimes they'll include this disclaimer here that they want you to only use integers and the integers need to be greater than or equal to 1. This is simply just them being ultra conservative and ultra thorough with their variables here. You would not use a negative number because you can't have a negative number in a sequence. You could have a negative number in the sequence itself, but the term number would never be a negative. So they're just making sure that they're being extra thorough here and extra clear. They want us to find the first 3 terms of the sequence. So we're going to plug in, or find S sub 1 by plugging in a 1 for S, or a 1 for N, excuse me. And we're simply going to calculate 1 in place of the N, and now we're going to calculate here. 1 plus 1 is 2, 2 times 2 is 4, 4 plus 15 would be 19 is term number 1. Then we would find the second term in the sequence by plugging in 2 for N. So again, we revisit the original equation, and instead of a 1, we plug in a 2. So 2 plus 1 is 3, plus 2 is, or excuse me, times 2 is 6, plus 15 is 21. At this point, you could probably make a guess on what the next term is going to be, but if this were a test or a quiz, I'd recommend going ahead and continuing your current method of simply calculating it. Now we're going to plug in 3 for N. I'm predicting that it's going to be a 23, but let's go ahead and calculate just to make sure. 3 plus 1 is 4, times 2 is 8, plus 15 is indeed 23. So I got my first 3 terms. Now they ask for the 50th term as kind of a follow-up question, so I'm simply going to say S of 50. So I'd plug in 50 for N, and I'd recalculate. I know I'm going to get a much bigger number this time, and so I'd probably use a calculator on this one. And when I do that, I get 117. We're going to go ahead now and try a problem from the homework. This one involves some powers, so I want to have students try that. Let's just read through the question first. This is number 14 in the homework. We are only going to do part A together, and students will be asked to do part B on their own. Some common bacterial cells, such as E. coli, can divide and double every 20 minutes. The doubling process takes place when a microbe reproduces by splitting to make 2 cells. Each of these cells then splits in half to make a total of 4 cells. Each of these 4 splits to make a total of 8, and so on. Each splitting is called a generation. If a colony begins with 125 microbes, the equation P sub n equals 125 times 2 to the n minus 1 power gives the number of microbes in the nth generation, assuming all microbes survive. Calculate the first 3 terms. So this sequence is a little bit different from any of the others that we had done today. And so I wanted to try that with some students, or with you in the video here, just to make sure that you're comfortable. So if we're trying to find term number 1, we would substitute a 1 in for n into the formula. So that means I'm going to do raised to the, so I'm going to actually type in that caret symbol to help me remember that I'm doing a power here, and it would be 1 minus 1. So that means I'm going to be plugging in 2 to the 0 power. Now I remember from my previous math skills that 2 to the 0 power is simply going to be a 1, and 1 times 125 is 125. So I know the answer is 125, but if you aren't comfortable with that, or if you didn't know that 2 to the 0 is 1, you could simply type it in as is on your calculator. Now let's try P sub 2 for the second term. So that would be raised to the 2 minus 1. I know that that's going to be 2 to the 1 power, so I'm simply going to do 125 times 2, which I know is going to be 250. So again, I'm using a little bit of my head here rather than relying so much on my calculator. I know a lot of times when students see that there will be an exponent involved, that they automatically assume that they need a calculator, but in this case I wouldn't say that that's entirely true. So now we've got it raised to the 3 minus 1 power, so we know that's going to be squared. 3 minus 1 is a 2, 2 squared is 4, 4 times 125, I know it is 500. So I've got the first 3 terms there. There is a part B to this question that I will ask students to do on their own. During class today we'll probably do number 6 as a ticket out the door. So if students want to try this here, they're welcome to, and then the answer is provided at the end of the video and at the end of the lesson.